Hi guys, welcome back to my channel. My name is Ramsey, and today we're going to look at yet another pattern in our series on building effective agents. If you've been with us on this journey, we've implemented so far 4 patterns. We've done prompt chaining, we've done routing, we've done parallelization, we've done the orchestrator workers pattern, and today we're going to look at yet another one that can be very powerful if you know how to implement it correctly. This is the Evaluator-Optimizer pattern. I'm going to jump right into it. There are a lot of goodies today, like lots of cool stuff you're going to learn, and I can't wait to go on this journey with you. So fasten your seatbelts. It's going to be an awesome ride. Right, so I got ChatGPT to sort of help me generate this, to kind of like bring in the concept of what the Evaluator-Optimizer pattern is. The original image from Anthropic is this, where you have some kind of input, and then one LLM generates an output, passes it on to another LLM that evaluates that output, and then this LLM either accepts the output or it rejects it and gives feedback back to the original LLM, which then has to generate new output, incorporating this feedback. So, how do we do that? Or rather, what are the key features of it? We'll get to the how we do in a bit. What are the key features of this pattern? So basically, this pattern pairs one optimizer LLM, like a writer, with an evaluator LLM, like an editor, in a feedback loop. The optimizer generates, the evaluator scores, and then the optimizer revises, or you get an output out of the system. And it works in a feedback loop, like I said, getting out when scores achieve a minimum. So there must be some kind of check being done to determine if scores have achieved a minimum. You can see here, again, another image from ChatGPT that involves generating, evaluating, and then you sort of just repeat that pattern. When should you use the Evaluator-Optimizer pattern? Okay, so let's say you have clear quality criteria for the evaluator, like if it's like writing and you're trying to evaluate like some kind of rubric that you can use to do that. It's also if you have evidence that feedback clearly improves your output. For example, you know that if you just one-shot the task, like you just try to get the LLM to generate once, then you're not likely to get very accurate output. But if you few-shot it, then it significantly improves the quality of your output. In that case, an Evaluator-Optimizer pattern would be pretty useful. Some cases of this would be like nuanced translation, where you want the translation to sort of like fully capture the message of the original text, or prompt generation, where you want to continuously improve the kinds of prompts. Like if you're working with AI to help you generate prompts to put into other AI, then you can have it improve its prompts over time by setting up this kind of feedback mechanism. And also, if you're willing to trade cost and speed for higher reliability or security. I don't know why I said ought. Sometimes I make these mistakes. So let's say, for example, you have some kind of output, like let's say you have a chatbot, and you want that the chatbot's output is sort of like checked to make sure it follows policy, or it's clean, or it doesn't reveal anything sensitive about the underlying app or logic. Then you can have an LLM that evaluates the output and keeps giving feedback to the chatbot before that output like appears in like a text window or something. So that kind of stuff. In that case, you might want to have high reliability and security, and be willing to pay the extra cost, because in the Evaluator-Optimizer, you're doing several LLM calls in a loop, which means your token costs are going to be high. Okay, so we're going to do a demo as always, and behind this demo, there's like a lot of like really important concepts. So we're going to cover them, and then we're going to build. Once you understand these concepts, they're not very hard to understand, but once you understand them, it kind of like unlocks a lot of places where you can use this pattern and other patterns that involve looping in N8n. So Basically, we're going to create a translation kind of system. So we're going to input the text that we want to be translated, and then a translator is going to translate the text, and then an evaluator is going to judge the translation based on some kind of rubric, like, how is it nuanced? Does it capture the poeticism of the original, that kind of stuff? And then it's either going to accept the translation and output it, or it's going to give feedback to the translator so that it can generate another translation. So that's what we have here. So, translation goes one way, feedback goes the other. There are two important concepts here that are going to make us able to implement this. These are looping and state management. Looping basically involves iterating, right? So you have some kind of loop, and in each iteration of the loop, there is something you're doing to data, and there are some other pieces of data you're remembering, okay? Now, the data that relates to the loop, like it gives like extra information, almost like meta information about certain facts, certain pieces of data about certain pieces of information about your data. That is what we call state data. And that's what you want to manage in your loop. So I'm actually going to go through some possible state variables, right? Like knowing what number iteration you're on. Have we looped 3 times, 4 times, 5, once? You might want to keep that information in each iteration of that loop. What's the original text we were given? This one would mostly stay the same. So the iteration count will change, but the original text will stay the same. The target language, that is, what language are we translating into, that will stay the same. The highest scored translation so far. So at each stage, you want to keep updating that. So that will change. And the highest score, so that's associated with that with the highest score translation, that also changes. And the latest feedback from the evaluator, you also want to keep track of that. And that also changes, right? Because it's giving different feedback at every iteration. So the idea behind looping is that you iterate, evaluate, improve, and then you repeat until either you have a pass or you've done a maximum number of iterations, because you also don't want runaway costs. I mean, if it's an infinite loop, you're soon gonna go broke, because OpenAI will take all your money, or whatever AI API you're using, right? So you need a max number of iterations and some condition for passing as well. And you need to update the state on each pass. This is what I'm calling state management in this case. I don't know if it's the proper industry term, but I'm just kind of like borrowing some concepts from programming. So you need break conditions, like if the score is above a certain level, or you've iterated a certain number of times, and you need some kind of failure branch where if the score is below threshold, then you send feedback back to the optimizer, and it generates the next candidate for being scored. And there's a success branch where if the score is above the threshold, the output is done, right? So it's kind of like this kind of thing. If you think about it as a diagram, you have an action, then a condition. And if the condition is true, then you output. If not, then you feed back into the action. And you can kind of like see how we would implement that. So this is just like a rough like diagram show it. So you'd have input, and then you'd be setting some state data. So, these little variables, you'd have like some starting values. Obviously, the highest score starts at 0, and the highest score translation is probably like just an empty string. And then you're going to do something with the input. So this would be where you have like, the translator translating, and then the evaluator evaluating. That's what would fit in this box. And then after that happens, you'd update the state data. So what has changed? What's the new highest score? What's the latest highest score translation? The first translation, is always going to be the highest scored translation for that particular run. And then after that, the second translation might be better, might be worse. So depending on that, both that data can change. So you update the state. And then, does output match some condition? Like, is the score above a certain threshold, or have we done already a certain number of iterations? And if the answer is yes, you give the final output. And if no, you pass the input back. Now, this is interesting because what makes this work is that there's, again, input-output contracts. The input that is going to be expected here should have the same shape. They should be the same sets of keys and values, as the output from the update state data. So like, let's say the first input says, okay, this is the original text, this is the target language, and this is the highest score. And then what gets fed in the next loop is, oh, okay, here's the same list of stuff, but this is, you can see some have changed. This is the highest score, this is the original text, etc., etc. It's easier to see when we do it, in here. So I actually kind of already built this, where we have some form where you would enter the text to be translated. And then this is what I was saying, setting the state. So initializing state, and you can see here, I initialize some values. Basically, it's just like a set node. And then we have a prompt building step here. And the reason why, you need to build a prompt is because depending on whether it's feedback or it's the first run, this is either going to be a generator or an optimizer. We're going to give it a different prompt depending on what task it's supposed to do. So if it's just generating, we're like, okay, you're a translation agent, translate this. If it's an optimizer, you're like, okay, so could you correct this translation based on this feedback, that kind of thing. And then I kind of just like maintain that dynamism, building the prompt for the evaluator as well, because some stuff might also change from one run to another. So you need the prompt to be dynamically built. And then you set the new state variables, you update, and then you check for pass or max iterations. If it's true, it goes up. If it's false, it comes back. But to help drive this home, let's build it together. So the first one is a form. As you can see, I'd already kind of started something here. This is the Evaluator-Optimizer pattern. And I believe I had given it a form title, so text translator, and a field name is the text. And this is where the text to translate is entered. So, you can also always add more fields. So the other field is target language. And you can see it's a text field type. And the placeholder would be target language for translation, right? And we can make it a required field. So you can toggle this on and off if you need the field to absolutely be filled. And you can add more form elements. We're just gonna have it at that and maybe test the steps. So for this, like I'd had some really cool text I found in German that's really hard to translate in English. So you'll find that a lot of languages, translations can sometimes be tricky in some languages because of some concepts that just don't carry over as easily, or some nuances. So I just went and randomly looked for the statement. I don't remember what the translation is, but I mean, we could Google it later. But anyway, so I'm just gonna test this step, and I'm going to add that text here. So that's what I want translated. I'll just get rid of these, what they call quotation marks here. And then the target language, of course, will be English. I don't know why I did camel case, because it's a form, but bear with me. And then, so let me just check that it's still listening. I'm going to submit, and okay, so there we have it. So you can see I got the target language and the text. Now, good practice usually is when you're working with workflows, building your workflows, sometimes it's good to pin data so you can reuse it in future nodes. So here, I'm just going to click on pin data. That's that button right there. And now I have access to this for the rest of the time we'll be building this. Now, the next thing, as you can see in the original thing, is that now we set some state data around this input. I have a set node that I built here, and I'm going to just repeat that. So I'm going to have a set node. And you'll kind of see the kind of data we add. It's motivated, so it's important to some of the stuff we're going to use later. So first we have the iteration count, which is going to be a number. So I'm just going to have this as iteration, just like that. And it's going to be a number. It's very important that you remember to pick the correct type for your set fields. And then we're going to pick the source text. So this is the original text to be translated. So I'm just going to name that field source text, because we'll need to use this later. Of course, it's going to be a string, and the value is actually going to be dynamic. So it's going to be coming from the text from the form. So I'm going to pull that in there. And then we are going to add, I think, the target language, right? So yeah, target lang. I'm just going to have that variable name there, right? So target lang, let's see. target lang, and it's going to be a string, of course. And again, we're going to pull the variable in here from the form's output. And then we are going to add another field. This is going to be the best translation. This is going to be the best translation so far. Remember, we kind of like gave a few examples of some state variables we might want to keep track of. So the best translation so far is going to be important. And we're just going to have that there, best translation. And for this, we are going to have an empty string for now because it's going to start out as an empty string. And then I think we're going to go for, I guess they're doing feedback summary, best score, whatever. So let's go for a feedback summary. So there's going to be like a summary of the feedback. So the way I had built it is that the evaluator LLM is going to give like a short feedback summary and then like a list of feedback points back to the translator. So like the feedback points would give like finer details on what the translator needs to revise, while the feedback summary is just like a general description of what the evaluator thinks of the current translation. So that's why we have these two different variables. So one is going to be a string and the other one is going to be an array because it's going to be a bunch of points, like bullet points, right? So the best way to represent that would be using an array, which is just like a list of items. Right, so let's have the feedback summary right here. Feedback summary, and then there's going to be a string, as we said, and then we are going to. It's going to start as an empty string, obviously, because the first feedback is no feedback. And then we're going to have the feedback list, and this, like we said, is going to be an array, and it's going to be an empty array. So we'll just leave that open because it's going to be an empty array. Of course, you can have this, I guess, it gives you a result, but if you leave it blank, it'll still also output an empty array. I mean, you can kind of like see that here if I just test this step. Oh, sorry. Oh, wow. Humble pie. You actually need to indicate the array notation, which is the square bracket thing. So now I think it should show correctly. Yeah, now the feedback list is an empty array. And then the best score, you want to keep track of the highest score. So that's going to be a number. We're just going to add a field here and say best score. And we're going to make that a number. And of course, it's going to start as 0. And now if I test the step, we can see that we have this. So this is going to be our initial state data. And now this is what we're going to keep changing with each iteration by keeping track of. So we can keep track of these variables. Okay, so what's the next step? Well, now we've set the state data. We can go right into the loop. Basically, this do something part, right? So the next step here would be to, of course, generate the optimizer and the generator optimizer. As you can see, I'll be using a code node because we're going to implement it in code. So we're just going to, oh yeah, and by the way, it's really nice to name your nodes as you work. So it just helps people understand what they're doing. So this would be the translation from, I'm just going to use the same naming I used in the original build. I think this is going to be set state or initialized state. I think that's what I called it, initialized state. And that should be, yeah, that should be correct. So now we're going to add another node, and that's going to be a code node. And so here we're going to have it run once for each item. You can either have it run once for all items, or you can have run once for each item. Sometimes I like to use this because we know it's only one item coming through the table of state data. So it really doesn't matter. But like I like this because it gives me like a convenient access to some of these this JSON thing, so I can manipulate it with code. Anyway, I'm just going to copy paste the code. I don't want to go too much into the details of it because this isn't a coding lesson. This is something about building with N8n. You can actually have this generated with AI if you want. If you're not a coder, you just need to now describe to it what you want it to do. But like, if you know in advance, I knew in advance, and I actually used AI to help me generate this code. But the idea was basically, so you take, this is what I meant, like you can access the variable, the table through JSON. And this is like basically initializing an object, another object. And I'm just like saying that these values, like the iteration, source text, target lang, best translation, feedback summary, and feedback list, are coming from whatever the JSON object has. And you can see that it actually does have all of these. The only thing I don't include in here is the best score. That's because I won't be using it in this particular code block, but I will use it later and we'll access the same variable later. Anyway, so the next thing we do here is we create, because like the feedback list, it is coming as an array. To make it easier to feed to the optimizer, we kind of like turn it into a bullet point list. So that's literally all this code is doing. It's just like basically adding a bullet point to the text of each feedback item in the feedback list, and then adding like a little enter at the end, like a carriage return, so you have them like stacked on top of each other. And basically it says if it's the first iteration, so if the iteration is 0, it has like a prompt that says you're a translation writer, and then it gives it like a task, and then it dynamically takes like the source text and target lang from whatever we got in the form. And the reason it can do this is because it kind of like set that variable already here by taking whatever I was getting from the set node. And then if it's like the iteration like the second or third or higher, then the prompt changes, like you're a translation writer, professional translator improving a draft, and then it gives the input, and it gives now the best translation from like the previous run. Remember, we're keeping track of the best translation at each run, and the feedback summary from the previous run. And then it has like an extra feedback loop where it pulls from like this little thing we created, like this bullet point that's called the bullet block. And then it finishes the prompt, and then it just returns. So in this case, I return both the state data that I'm taking from the set node, because we'll use it later further downstream, and also the prompt that I just created dynamically. And then you take that, and basically I'm just gonna like test this step so you guys can see what I'm talking about. And you'll see that it's going to generate a prompt because it's literally the first iteration. You can see we set it as 0 here. So I think it's waiting to execute. Why is it waiting to execute? Okay, there, it actually ran. And you can see here, it gives me the initial state data, right? So I still have the stuff, but it also gives me the prompt, which you can see here now has like the source text is our original German, the target language is English, etc. And now we can pass this to an LLM call. So next, you can see here that I basically just like do a messenger model node. So we're going to call this the build generator / optimizer prompt step. Okay. Build generator / optimizer prompt. And just going to rename that and save. And now we can add the messenger model node to use that prompt with. So we're going to go for OpenAI and then messenger model. And for this, so this is really interesting. So AI is surprisingly good at translations. So finding a model for OpenAI that couldn't do the translation very well was extremely hard. In the end, I had to go for GPT 3.5 Turbo 16K because that was like the only one I could get to sort of semi-reliably do bad translations, so we could see more iterations, just to demonstrate the concept. But yeah, later on I was like, okay, maybe I should have chosen a different idea for this demo, but with this one I had to work with what I had. So the prompt here, interestingly, we're just going to pull the prompt from the code node, so it's just going to be a variable in there. And of course, it's going to be a user prompt. Now you can see that if you test this step, OpenAI will do the thing and it will have the translation here, right? Now what we need to do is, of course, first rename this, but then after that, go to the evaluator step. Although there's some like steps in between, which we'll talk about in a moment. So this is, I think this is the generator / optimizer. What did I call it? The generator / optimizer. Okay. And we'll rename that, and then we'll come here and we will set some variables for the evaluator prompt builder. So we're going to build the prompt for the evaluator dynamically, just like we did for the generator. And before that, we're going to have some variables set for it. So I just like to do this because the output of the Generator-Optimizer is going to be the translation. So we need to sort of like have a set node to just access like variables we'd set earlier or had processed earlier, so that we can then like pass these on to the evaluator reliably, the code node reliably. So we're just gonna have another set node here. Let's see, set. And here you can see, based off of this, we pull in the source text. So we need to maintain the source text because the evaluator will need it. So we're just going to add a field here and call it source text. Of course, it's going to be a string. And to pull the source text dynamically, we'll just go back to the build Generator-Optimizer thing. That's why I had it pass on the JSON, so I can just like access these state variables further downstream. So the source text goes there. And then we're going to add another one. I think the target lang, I'm not sure, but yeah, right, target lang. So the evaluator will need to know what target language we are trying to translate to. So I'm just going to pull that again from the previous code node. And then finally, we're going to have, I think, the current translation, which is whatever translation has been given by the generator. And because that's what it's evaluating, right? Basically, it is going to be the output from the generator. So we're going to take this content and pull it in there, and we have that. Now, just so you can see how we're doing this, right? So we had the generator here. I hope I don't know if you guys like actually wanted to see the prompt for the generator, but like I think it's supposed to be here. This is where I learn it. Not the prompt, but the output, sorry. Actually the prompt, yes, the prompt. So you can see here, basically, I just tell it, I do give it some instructions. So I'm like, produce a fluent idiomatic, translation of source text into target language, and then preserve meaning precisely, no omissions or additions. So I just had ChatGPT help me write this prompt for the demo. Mirror the tone and register of the original, adapt cultural references naturally or clarify if needed, and then length, it should be less than or equal to 120% of the source, which just like helps. And then output only the translated text, no explanations, and begin your translation. So based on these, you can tell the evaluator, again, like I told you, you need like clear quality criteria. You can tell the evaluator what to evaluate on. And that's what building the prompt is about. But we're going to do that in the code node. First, let's just rename this real quick. I think I named it set variables for evaluator prompt builder. Okay, so set variables for evaluator prompt builder. Okay, so we have that, and I'm just gonna rename it. And then now we're going to have a code node to actually build that prompt with some dynamic variables pulled in there. So I'm just going to copy the code here. Again, I'm not going to go into too much detail, just cover it briefly. So basically, you just give it, so you take, again, remember what I told you, initialize an object, and then you take these variables right from the JSON. And now here, don't forget to say run once for each item if you want to access that JSON. That's why that red squiggly line was showing, because it was like I can't access it like that if I'm on run once for all items. Okay, so prompt is your translation quality evaluator. Your goal is to judge a machine-generated translation against the rubric below and return a structured JSON report. So the inputs, so we pull in the dynamic variables, the current translation, source text, and target language. And then the rubric is here. So accuracy, so does the meaning match? Fluency, is the translation grammatical and natural? Cultural and stylistic appropriateness, are idioms, tone, and register correct? And instruction following, does the translation obey any style or length format constraints provided? Like if I wanted to provide that in the prompt, I didn't, but basically that. And then you aggregate the subscores into overall score. It's always good to give your agent, because we're going to have it output, the scores in a structured way. So we're going to use an AI agent for that. So you need to give it like the shape of the output so it knows what to output. And then later on, you can have like an output parser, make sure it actually obeys that kind of output. And so that's what I'm doing here. So it needs to say whether it passed or failed, give the overall score, and then break down that score based on these four. We're going to have the feedback summary here, and then the detail, which is going to be the array. We had spoken about this earlier. A few more rules here just to, sort of like guard ourselves against bad outputs. So produce only valid JSON. Feedback must be actionable. Replace literal word order with natural target language syntax, not bad translations. So just to give specific feedback. Never rewrite the translation yourself. Critique only, and if overall score is less than 85, pass must be false. And then end of prompt. So again, ChatGPT helped me do this. And then we just output the prompt from this code node. So we're just going to rename that. So build evaluator prompts. Let me just rename it and then we can test it real quick. So build evaluator prompt. And then I'll rename this. And now if we just, okay, so we might need to run this first just to see that we actually, actually getting output here. So there are the variables, and then now we can run this and it should now have the prompt prepared. So you can see here actually that if you look at the source text, shows the original source text and then the candidate translation and stuff. It's really cool. Great. Now we do the evaluator. So because I need the evaluator to have the output in a certain shape, with the messenger model, you could tell it to give the certain shape, but you can't like have an output pass. And I always like having an output pass just to make sure the output is correct. When AI needs to give out structured outputs, so in that case, since you can't use messenger model, you just use AI agent. So the AI agent node. And of course, the input is going to be defined below, and it's just going to be the prompt that we built in the previous node. And then now we can say it requires specific output, which allows us to then add an output parser, right? Let's see. So we are going to add a chat model here, and I'm going to go for OpenAI. What did I use in the original build? I think I used like a reasoning model for the evaluator, because it's just doing this whole thing. You need a strong model. Oh, I use GPT 4.1. That's not too bad. We could use that GPT 4.1. I'll just pick the latest one. We need to set temperature here. I don't know. I think it should be pretty creative. I don't know. Did I set temperature here? I have to check this node, right? No, I did not. I guess it can be as creative as it wants, especially since it's doing an evaluation. But it must give a specific output. So we need to add the structured output parser. And for the shape of the output, we're just going to pick whatever we gave as the shape in the prompt that we were building for the LLM. So I'll just copy that. So that allows us to come back here and, we say generate from JSON example, and then this shape will just serve as an example. So the output parser knows to expect that. I don't know what this is. Why is it showing this? Unexpected token. Probably something about like some carriage return somewhere. Is this helping? No, it's not. I bet if you just like do this, it's just gonna transfer. It's always weird when that happens. Unexpected token, pass through, blah, blah, scores. I'm just going to then, just to avoid that, just pick the shape I defined in the output parser from my previous build. And then we'll just have that right there. And it should fix that. Okay. So now we've got the evaluator. You can even name it that, right? So we'll just rename this to evaluator, right? And now we can test this step, right? See what it comes up with. Hmm. So let's change my Wi-Fi. Right there. So I can't connect to N8n. So now I can connect. Okay, so let's just save that again and now run it. And let's see what it comes up with. Is it even running? Hmm. I have to do something different here. So let me just um, okay. So let's see now. So it does give the output. You can see it says pass, false, scores, and then gives the accuracy, fluency, culture, and instructions, and then gives the feedback. Here's a summary, and then here's the details. So it's a numbered list. Okay, so maybe we can just continue from there. So we have that. Now the next thing is we need to now loop this back. So how do we do that? Remember we said here that we would now update, we've finished to do something. With update state data, check the condition, did it pass or fail, and then loop it back. So we're going to go to that. You can see here actually the next thing we're going to do is this set some state variables with code. So the reason why I use a code node first, I'll share in a moment, but let's just have it in and then I'll explain it as we go through. So we have the code node here and I'm just going to copy the code from here and then explain it a little. But let's see. So just going to copy that and then paste it here, right? And oh yeah, by the way, again, the credentials for the AI nodes. N8n has excellent documentation on how you can connect the credentials. I'll link the article to getting OpenAI credentials below. Anyway, let's go back to the code node. So this is what's happening here. Again, creating an object. So we're going to change the iteration. It's going to be the iteration. So you can see here that I'm pulling from whatever the optimizer prompt thing. Because remember, basically, I'll just use this other one that I built. That the optimizer prompt builder right here had output both the JSON of the initial state that we had set here, right, as well as the prompt. So we can really access this from within the loop and just keep adding or changing state data. So I'm just pulling from that. So I go item.json, and I know this is showing these squiggly lines because again, I need to do run once for each item. And that makes things a lot easier. And then we've got the best translation. So it takes, again, the best translation from the prompt, from the code node, and then the source text, target lang, overall score. And then now the overall score, it takes from, so it accesses JSON, it takes from the evaluator's output. Remember the evaluator gives the overall score, so it takes that. That's what it's doing here. So that's why I have this reference, JSON.output. That's this, dot overall score. And then the same thing with the pass and the feedback summary and the feedback lists, where it just takes the array. And the current translation is whatever the generator-optimizer had output in the content. So you see you access it with .item, .json, .message, .content. You can usually have these things easily just by like dragging. So if like I dragged, for example, right here, you can see it automatically grabs these references for me. So don't worry about like where I got like these. So you can just drag and it writes it for you. So first it checks if the overall score is greater than best score. And remember, our best score starts at 0. So this will obviously return yes is better. So if it is, then the best score is now whatever is better is the variable. So this is, I think it's called a ternary operator, where like you say best score, and then so this is like JSON, so it's similar but a colon, and then the value is going to be dynamically determined by the value of is better. So you check if is better exists. It's just like a small check to make sure we don't like deal with like null values or something. Again, it's programming, don't worry about it. You can have AI generate this for you, but then it just checks. And if it is there, then if it's not there, then we use the overall score as the so like it checks if this is true or false. So is the overall score greater than the best score? If it is, then we use the overall score. If not, then we use the best score. Again, is better best translation, we check again if the overall score is greater than the best score, and then now the best translation becomes whatever the current translation output by the generator was. Of course, we add a data for pass to say whether it's true or false. So just like put it in there. And then source texts, target lang, current translation, feedback summary, and feedback list. As you can see, this is following the exact same shape as the initial state data we had here. The iteration, the source text, target lang, best translation, feedback summary, feedback list, and best score. It's the exact same shape here. Iteration, well, it does include best score and stuff, and we can reorder it, but it doesn't really matter the order. It's just that you have a JSON object of these pieces of data, because that's what you're going to be keeping track of on every iteration. So we're just going to call that, what are we going to call it? It's not initialized state, it's set new state variables. Okay, set new state variables. And guys, if you want me to do any videos on how you can use AI to help you generate code, please let me know. I mean, vibe coding is all the craze now. I'm sure most of you know how to do it, but if anyone actually wants to know some tips and tricks, let me know and I'll make a video about that. So you can see now, we now have the iteration updated. It's the first iteration. The best score is updated, it's the latest best score. The best translation is the latest translation from this first run. We can see pass is false. We still have the source text, the target lang, the current translation, the feedback summary, and the feedback list, which is an array, right? It's an array, but remember when we were building the prompt here, we kind of converted it into a bullet point list, so we know it'll be handled when we loop back. Now we just have a set node where now we, take these. Like we kind of have all of these happening, and we could like literally loop from here. Actually, I think it may not need the set node, but what we do need is, so I don't know why I added the set node. I guess I just kind of like over-engineered it. We don't actually need the set node because the output of this code node is exactly what we need, right? So we're just going to go right to the condition checker. We're doing like an if node, and basically we're just going to reproduce this. This is like checking for pass or max iterations. And maybe because we realize we don't need a set node, we can just like quickly rename this to update state, right? And there. So so what did I say? Check for pass or max iterations. Just going to rename that as well. Check for pass or max iterations. And then so we're going to set what we're doing. So you can see in here, we're basically checking if the iteration is greater than 5. So if we've done more than 5 loops, and we're checking if we passed. So checking the value of pass to be true. This is exactly what we're going to do. So we're going to take this and drag it in, and it's a number. So we're going to come here and pick number. And then we're going to go for is greater than or equal to, and then we're going to have this as 5. And then we're going to add another condition, and we are going to have pass, right? And pass in this case is a Boolean. It is a yes or no answer. So we're going to have Boolean, and then we're going to say is true. So is it true or false? And now this allows us to do this, where we get the false branch is where our data went through. So it's routing correctly. Now, had it been true, we would just have this as a set node, as you can see here. And that's exactly what we do here. And in that set node, we just have translation. We output whatever the best translation so far is. So I'm just gonna say translation, and we're gonna say in here it's gotta be the best translation. We can't access any variables right now because it went through the false branch, but I could just copy this because we've literally been building the exact same thing and just put it here. And whenever it's going to resolve to the true branch, it's going to just get that right. And we're going to call this output translation. Okay. And now for the false is where the magic happens. You guys ready? Okay. So what the hell? Sorry. You pull this all the way back and you go back to the build generator, just like that. And your loop is complete. And what happens is the output that's coming from here, right? The output that's coming from here, all this stuff, the iteration, the best score, all of this other stuff is the same one that this will be able to access through this little object, because it'll just pull it from that input. It's going to pull the latest value. So here it says 0 because it's coming from the initialized state, but here it's going to say 1 because it's going to come from the loop back. And we're just going to do that and see, because you can't test this like from here. If I play this, it's just going to like probably pick the input from the previous node. As you can see, it's picking. So for it to pick the input from this line, just test the whole workflow and let's see what happens. Let's see. It's doing another run. Can you guys see that? Oh, sorry. Oh yeah, so sometimes, again, this is just like one of those gotchas that happen with LLMs. I know exactly why this is happening. It's because the evaluator didn't return anything. It returned an empty object. And sometimes, again, with outputs, whenever LLMs have to give structured outputs, it's a probabilistic system. So you don't know if you're going to get the structured output every single time. And that's why you have to be really careful how you use LLMs in your workflows. You need some kind of like guardrails to make sure that if something like this happens, you have some kind of fallback plan. Of course, here maybe we would have used a different model, or we would have like some default output shape or some other like error workflow that maybe goes and repeats, like re-triggers this workflow to start again. In this case, I'm not going to add that complexity to this video. It's already long enough. We're just going to run the workflow again. And I'm sure this time the LLM will output a proper shape. Oh, wow, it didn't. Let's see if it does it third time. Might be a charm. Let's see. Oh, wow, it's still outputting nothing. So what's happening here? Let's check the structured output parser. Okay, so maybe sometimes when I see these things and just play around with it, like maybe I just try a different model. Like maybe let's try O3 for this. Like O3 mini, I only have access to O3 mini. So I'll just take the latest O3 mini and let's see if that helps. And see if it's actually gonna do better than 4.1. There it goes. O3 mini does much better than 4.1. So now you know something. O3 mini is better at structured outputs than 4.1. So this is the second iteration you can actually see. And now it's on like the third one. Wow, that's a lot of revisions. Let's see what happens now. Wow, why is it still running? Let's see if it's like actually getting anything. Let's look at the second run or the first run. Oh, it's still outputting iteration as, oh, now it's outputting 4. Let's see. Best score is 89. So that might be the problem. So I think the problem is right here. So you can see the best score is demonstrably increasing. which means the past should be true. So, oh, it's because I had used the and. Okay, so what you really want is to be an or. So either the number of iterations is 5 or the past is true. That's why we were going on an infinite loop here. Oh my God. Let's do it again now and see what we get. Okay, well, actually in this one it got it right on the first pass. So you can actually see, and you know, if we go back to like previous executions, I'm just gonna do this for your benefit. If you go to like a previous execution here, you can see, for example, because this is useful, you can see what kind of feedback it was giving on each run. So it would say like solid poetic translation minus talent. This one was actually a pass, and then it says refine the translation, consider blah blah. So even if it's a pass, it still gives feedback, right? And if it's a fail the first time, like I think if you look at like maybe some other run, I don't know if like on this one, for example, the one we just looked at, if we look at like the first, because if you go here, you can see its output. So you can see the first output. Yeah. So if you click on the first output, you can see it actually failed and it gave like feedback, you know? And then you can see that after that failure, if you go back to the Generator-Optimizer, the kind of prompt it was getting at this point, you know, would be something like you're a translation writer improving a draft, and then it gives like the feedback down here with like bullet points. You can see that. So it's really cool. It just goes in that like iterative cycle until the tight feedback until it gets a good answer. Here it did it in one pass, and we can see the translation is as everything weaves itself into the whole, works and lives in one another's role, like celestial forces rising up and down, passing the golden buckets around. With wings of blessings in their flight, from heaven through the earth they alight, harmoniously ringing through the all. Wow. So that's what that random German phrase means. Pretty poetic. But anyway, that's it. That's the Evaluator-Optimizer pattern for you. We'll look at something else next week. I'm not sure yet. But yeah, let me know what you think about this lesson. Let me know if you learned anything new. I'm looking forward to your comments, and let me know what kind of videos you want me to make. And if you'd like to work with me, I do lead generation automation for firms, helping you get leads around the clock. Please go to the description. You can access my agency's services page, and I'd love to work together. You can book a meeting, you can book a consultation there, and you can see how we can make your business much more efficient with AI and automation. So until next time, bye-bye.